So that just, it's just for our program coordinator, Lawrence Barlow, to introduce tonight's guest speaker. Are you ready, Lawrence? Yes, I'm ready, Lawrence. Not a problem. I can introduce him straight away. So this evening we have Mark Radice. He is an amateur astronomer and photographer based near Salisbury in England. A stone throw away from Stonehenge, if you pardon the pun. With a passion for observing the night sky, he is actively observing using a borrowed pair of binoculars when, well, he started actively observing using a borrowed pair of binoculars when comet, you always put these in to trip me up. Yeah.
Thank you.
Thank you. I was close. Across the sky in what was too many years now, and enjoys using his own equipment from his garden observatory. His astronomical interests include high-resolution lunar and planetary imaging, light stacking the deep sky, sketching and binocular observing, all with a cup of tea. How very British. Surprisingly, he was shortlisted for the 2021 Astrophotography of the Year competition, and Mark writes for Astronomy Now. He enjoys visiting dark skies and star parties in the UK and overseas, and also writes all too infrequently on his own blog at www.refreshingviews.com. So that just leads me to ask everyone to provide a warm experience Swinton astronomical welcome to Mark Radice.
Shall I share the screen then? There you are. So that should be coming across to you now. Can you give me a thumbs up if you've got it? Perfect. So yes, so good afternoon to you. Good evening to you. My name is Mark, and I'm going to talk to you about how I observe the planets. And really, I hope to show you why I enjoy observing the planets. You know, of all the things to see in the night sky, I do find the planets absolutely fascinating. And I'm going to show you why I enjoy it. And I'm going to use throughout the talk my own photographs, using my own personal experiences. And really what I want to do is just hope to encourage, more sort of active planetary observations through this talk. So just so that you know who I am, I'm going to kick you off with a little sort of personal introduction of what my interests are. And I'm going to use this picture throughout the talk. This is a picture that I took in 2018, and I actually captured all the planets in one night. So we had Mercury and Venus close to the Sun, Mars, Jupiter, and Saturn relatively in the middle of the night, and we had Uranus and Neptune right out in the depths of the solar system. So we caught all the planets in one night, and I'll come back to these pictures later. So as you were saying on your introduction, then I run a YouTube channel called Refreshing Views, and it's just a hobby. And basically, if you've got any more things you want to see or go through some of the processing and techniques and observing stuff I do, have a look at Refreshing Views. I should try and publish a lot more than I do. But anyway, you've got a lot of the details there, and you can see, my observatory, solar, planetary, lunar, whatever it is. I'll put some tutorials up on there, so have a look at those as well. So I started, well, I'd always been interested in astronomy, right from, when I was a child. But when I used to read the old Patrick Moore books, of course, to have a telescope, you had to be an adult. And you had to have a massive beard, I think, to be in a Patrick Moore book. And I was neither an adult, neither did I have a beard. So I didn't realise, and it took me a while to sort of realise that one could be an active observer. I always thought that was something, for adults to do. And I took my gap year after I left school, worked in Canada. And we had a talk from an astronomer called Terence Dickinson. He's a famous sort of Canadian amateur astronomer, writer. And he said, we're very lucky in 1996 and 1997, there were two really good bright comets. And he described how we could go and see them and go out into the night sky. And so this is my pencil sketch in a notebook. That's my first sort of proper astronomical observation. That was done with a pair of borrowed binoculars when I was working near Toronto. And comet Hyakutake is named after the Japanese discoverer. So that's it next to the plough, the handle of the plough. And so that was in March 1996. I tried to catch it the week before, but we were stuck in the snow. So very different weather from now. You guys are up in Yorkshire. It's probably normal conditions for Yorkshire, isn't it, now this time of year? So, right. So that was my first ever proper astronomical sketch. And although that was 1996, fast forward nearly 30 years, this is where I am now. This is my rolled off roof observatory in Salisbury, in Wiltshire, just down the road from Stonehenge. And that's me rolling the roof out and setting the telescope up at night. So that's what I've upgraded from, a pair of borrowed handheld binoculars, and now I've got a Celestron C11 in my own observatory. And there it is set up. So that was a picture we took. Do you remember in lockdown, we had the first lockdown, we had all that wonderful fine weather, and that's the telescope. And I'm actually photographing. I put the laser pointer on. Just there is Venus on the laptop screen behind. So I was photographing Venus, and of course, living next to Stonehenge, you've got to have your good optical alignments. And it was literally, I used to rush out and try and capture it. It went into that little gap between the trees after dinner. And I must admit, having an observatory is absolutely wonderful. It is so convenient. It takes me longer now to find my keys, make a brew, make a cup of tea, and go out to the shed than it does to set up. I don't have to run power cables, no polar alignment, no packing away in the small hours. So I do really recommend having an observatory. My wife and children wanted to have a hot tub, and they thought this would be brilliant because the observatory's got a warm room, and they thought, well, they could get changed in the warm room, roll the roof back, sit in the hot tub underneath the stars. But luckily, common sense prevailed, and it still is an observatory to this day. So that's my telescope. That's the C11 photographing Venus. And I've started to get really into this live stacking business. So instead of doing visual observing, I've been starting to experiment where you use the camera and you stack live on the video screen and on the monitor behind, in real time. So you don't have to go and do all your post-processing. You don't have any of the sort of downsides of imaging. You get this wonderful views on the monitor, within a matter of minutes. And we were at the Kelling Heath Star Party in Norfolk. My friend Lawrence and I, we went up there, and I was visually observing, we were looking at the veil, and he was live stacking the veil. So I went sort of round the back of the caravan, so I was away from the sort of lights from his laptop and the sort of light pollution. So I got really well dark adapted. Over about 45 minutes, made this, what I thought was quite a nice sort of pencil sketch, catching all those delicate tendrils of the veil supernova remnant. And after 45 minutes, he said, hey, come around here. We've got it all set up. Come and have a look at what he's got. And so there's me. I've been behind the back of the caravan, maintaining my night vision, being really careful. And I walk round to the front, and he's got his feet up on the table. He's got a glass of red wine. He's got his laptop all screened off so we don't disturb everyone else. But he's got his laptop set up. All this beautiful colour, all this details and tendrils, and he's sipping his red wine. And I thought, I'm going to have to start doing this approach. So that's what that is there. So that's NGC 891, which is this beautiful edge-on galaxy in the autumn sky in Andromeda. And what I like about this is with that same telescope, is you get all these features. You can see details inside the dust lane. And when I'm outside observing, visually, you can see the dust lane, but you certainly can't see details inside the dust lane. So with the power of the camera, the power of doing that live stacking, you do get to, turn your telescope really using that power of the camera into a massive, huge Dobsonian. So really starting to enjoy doing that. That's been my new growth area. So there's some more of the autumn shots. So again, that's NGC 891. We've got the Orion Nebula and the stars being born in the trapezium. And then this is one I looked at the other night, which is the Whale Galaxy. And it's been sort of tidally distorted by this satellite galaxy. They're sort of interacting with each other, and that's why it's got that weird distorted shape. So really enjoying live stacking using the power of the camera to bring out all those wonderful details and deep sky objects that normally appear as dim smudges. So this was taken at the end of March. I was quite chuffed with this picture. So there's a galaxy here, NGC 3079, which I'm sure you're all very familiar with. But alongside it down here, there's two sort of stars. And I think it's relatively recent, like the 80s or the 90s, something like that, only a couple of decades ago, when they were looking at the redshifts of these stars or the spectra of the stars, they actually realized that it's actually a quasar, and it's 8 billion light years away. But when you think the solar system's only 4.5 billion light years old, this is twice as old as our own sun, the solar system, and it's actually a foreground galaxy that's too faint for my telescope to pick up. But it's actually gravitationally lensed the light. The light's come out from this quasar, gone past this galaxy, and it's then been focused back towards us on the Earth. And I just find that incredible that, with that telescope, with a camera in my garden in southern England, in Wiltshire, I can resolve this double quasar 8 billion light years away, with amateur equipment. So that's why I love and really enjoying all of this observing at the moment. So as well as sitting in the shed, observing the night sky, I've also, this year went to the Florida to the Winter Star Party, which is sort of every few years I sort of save up the pennies and go out to Florida for this 10 days for the Star Party. And that's my travel setup. That's my Megray 90 William Optics Megray on a little Altaz motorized mount. And what I really love about this, of course, is one, it's February and the weather's really nice, and you get to sit observing by the Caribbean. And but you also, being America, you get to look through some really big telescopes. So that's a 32-inch Dobsonian there that you had to use the step ladder to reach the eyepiece. That was quite an amazing view of springtime galaxies looking through that telescope through a 32-inch Dob. Yeah, that's what my live stacking images are actually looking like through the eyepiece. And of course, being in Florida, you get to see all these exotic southern objects that we just simply cannot see from the UK. So there's the Eta Carina Nebula, Centaurus A, which is a colliding galaxy, two galaxies that are collided together, forming this wonderful sort of hamburger-shaped object. And this one made me laugh because this is Omega Centauri, but its nickname there was "Oh my God Centauri," because when you looked at it through the eyepiece, it was absolutely massive. An amazingly sort of detailed globular cluster, but they now think this is not actually a globular cluster. It's the dwarf, it's a core of a galaxy, the dwarf galaxy being swallowed up by the Milky Way. And that's the core, the original core of the galaxy that's been left behind. So it looks like a globular cluster, but it's actually the dwarf of a galaxy that's been cannibalized by the Milky Way. So yes, you get to see some amazing sights going down to the Winter Star Party. Right, so let's jump over then to what is a planet. So when I talk to my children, I say when I was at school, there were 9 planets in the solar system, but they changed the rules in 2006 or 2004, and they tightened up the rules of what makes a planet. So they came up with 3 rules of what they had to be. So in 2006, it was that they said the planets have to orbit the sun. So that rules out the moons, and you can see there the moon's going around Saturn. They had to be spherical, so they had to be big enough to become a spherical shape from their own gravity. So that ruled out a lot of the asteroids, and that ruled out a lot of the comets. And they also had to have swept their orbit clear, so they couldn't be orbiting around the sun with other objects. So that ruled out, in this case, that's Scepter Ceres as it went through the asteroid, went through the Hyades. But because Ceres orbits in the asteroid belt, that got discounted. So even though it's circular, spherical, and orbits the sun, because it's in the asteroid belt, that got ruled out. And likewise for Pluto. Pluto is way out in the depths of the solar system, and that was discounted. It's now been called a dwarf planet, and it orbits out in the Kuiper belt, right out in the edge of the solar system. So that's what defines a planet is. So we'll use that for this talk, the 8 objects orbiting the sun that are spherical and have swept their orbits clear. Okay, so let's go on to the next one then. So why go out and observe the planets? We've looked at that big Dobsonian, we've looked at all these galaxies. So why do we want to go outside on a cold, damp night and see these sort of beautiful, distant worlds? Well, first of all, I find them quite beautiful in their own right, visually attractive, deserts on Mars, storm clouds on Jupiter, rings of Saturn, all that sort of thing. But you also got this human contact. We sent space probes out there, and maybe my children or my grandchildren, will get there and we'll be starting to explore the solar system. But of course, we can see this ourselves now. We don't have to physically go and visit the planets. And I can say from the garden, go out and see and capture these photographs and these images and actually see them firsthand. So for example, then, if I go out and look at the Andromeda galaxy, and it's pretty well placed in the autumn skies again, it's really fixed. It's pretty motionless. You know, whether we look at it today, tomorrow, next week, next decade, it's not really going to change. There's going to be a supernova every, I don't know, 100 years, few hundred years. Whereas, of course, the planets, you know, they change from season to season. So unlike these features that we can see inside Andromeda, these little distant galaxies, of course, that's not going to happen if we go out and look at, you know, when we look at the Andromeda galaxy. But if you're going to look at the planets, of course, they're changing all the time. So that's me. That's out on the mountains of Tenerife. That's at the observatory. That's where, with Mark as well, your friend Lawrence. So this is us at the observatory. You can see the domes there in the background and the different instruments all set up. So that's my 6-inch Max-Utos Skywatcher Max-Utos telescope that I used to have, and I bought this secondhand. I bought it from a lady in a Asda car park. So she advertised on Astro Buy and Sell, and I met her in Bedford car park when I was working up in Milton Keynes. And so that telescope's been to Tenerife, and that's what I used to photograph all those planets in one night. And as you can see, it's a pretty good sky out there. And that's what we started with. That was the view from the summit at night. You know, got this beautiful sight, you know, with that sort of beautiful sunset. That's the La Palma down there, the next island over. That's the highest mountain, even though we're in the Canary Islands off the coast of North Africa. That's the highest mountain in Spain. So we have the Earth, of course, in the foreground as well, so as our 8th planet. Right, let me get my bearings then. So that is Regulus, and that's the question mark that makes up Leo. Now is Mercury just about to start setting, just about to go into the haze. And we have Mercury, Regulus, Venus, and the crescent moon. So what a way to start the night by having that view on our doorstep. And of course, the nice thing was, of course, all the clouds were down here, trapped by the mountains. So we were above the cloud layer and looking up at this beautiful sky. And while I was there, so this was 2018, we had a really good Mars opposition. So Mars was really high, really big. Sorry, beg your pardon. Mars was really big, but very low. It was very low in the sky from the UK, so down in Sagittarius and stuff. So I thought, brilliant, when we get to Tenerife for this week, I'm going to photograph all these wonderful details on Mars. And when we arrived, and there's my picture of it, we couldn't see anything at all. You just these dim and distant dusky markings. And Mars in 2018 actually had a global dust storm, and all the dust kicked off in the atmosphere and all the way around the planet, and you just simply could not see any of the features. You can see a little bit more switching to an infrared filter. The glow of the surface could penetrate through the dust grains, but of course we couldn't see any of these wonderful features that I was hoping to see. But while we were out there was actually a little sort of small dust storm blew in over the Sahara. The sky sort of went white and we had all this dust in the air. So technically, I've actually observed a dust storm on Mars through a dust storm on the Earth. And I thought that was quite cool, actually, this sort of planetary observing. We forget that sometimes we're on our own planet as well. So here we are on Earth in a dust storm, photographing a dust storm on Mars. So really excited. And of course, we had the next opposition. Mars oppositions are every 2 years. And so this is what I managed to get with the C11, looking at Mars in 2020. So all these wonderful details. And again, I'll talk you through how I have the observations of this. So you've got the polar caps, the desert features, impact basins as well. So we are really looking at a world. And so I started sending my images in to the British Astronomical Association, to the Mars section, and I had such a blast. We had all that fine weather in 2020 in the autumn of the lockdown, and actually one of my pictures made it into a BAA paper, monitoring of Mars. So there's observers, in the UK, North America, Far East, Middle East. So you actually get this 24/7 coverage, not just of Mars, but of all the planets as well. And there's mine. So my monitoring picture actually has got into a scientific paper as an amateur astronomer. So I was quite chuffed with that. So as well as being beautiful in their own right, and as well as being sort of scientifically interesting, having a monitoring program. Of course, if you're starting out observing and you're looking for, something to observe, finding the planets compared to a deep sky object is really easy because they're really bright. You don't need, sort of go to or even star hopping. As long as you can find these bright stars, and that's Venus and Jupiter in the evening sky over Stonehenge a few months ago. As long as you can see them, you can find them because they are that much brighter than, say, a small, dim, deep sky object. So as long as you've got your tracking, if you're going high power, that's all you really need. And say, with a wide-angle lens, or go on to it in a bit more detail, you can actually follow the planets relatively easily. So that's a good segue then into observing the planets. So let's go and start doing some of that. So we've got two real sort of considerations to remember. They're going to come out through this talk, and I'm going to refer to this all the time. So planets are really small in angular size. So when you look at deep sky objects or the moon or solar observing, they're a size in the sky. And when we look at planets, they're actually quite small in terms of angular size. And of course, you want to see features on these planets. Of course, you need to use high magnification. But the problem is, of course, we're looking, when we are on the Earth, we're looking up through the atmosphere. And the atmosphere is all turbulent. We've got the jet stream, we've got storm clouds, you've got different layers, and it all mixes up. So you've got this sort of conflict. You've got to use high power, you've got to use magnification, but of course, we're distorted by the seeing. So those two features are going to come throughout the talk. So what do I mean by seeing? What is an example of poor seeing? So this is a video I took, and we're going to process this later on in the talk. We'll turn this into a nice high resolution image. So that's a picture of Jupiter. And you can see here we've got the atmospheric belts, the storm belts that go around Jupiter. You've just got the great red spot about to disappear out of view down there. And we've got a little moon. And you can actually see it's a tiny, tiny little disk. It's not a star, it's a little disk. So whether you're observing or whether you're imaging, it doesn't really matter. You've got these constraints of trying to spot these planetary features, but they're small and they're on small disks. And the light comes from this planet, so you think the lights come out of the sun, bounced off Jupiter, comes back towards the Earth, and it's in that last fraction of a millisecond as it comes through the atmosphere, we get all this distortion of the, it's like looking through a river of all the detail. All that fine detail gets washed away through the poor seeing. So there's a few things to bear in mind when we're observing. So the atmosphere is the thing that's distorting the image. That's why professional astronomers build their observatories on top of mountains, like in Tenerife, or even put them up into space. So when you're observing the planets, make sure they're on the meridian. So this is where the sort of north-south line, this is when they're highest in the sky before they start dropping down there. So an hour or so either side of that is a really good time to observe the planets. The higher they are in the sky, the less atmosphere you're looking through as well. The other thing that makes a real difference is having, good sort of stable air. And this, I printed this off the Met Office only a couple of weeks ago. And it's very strange to think back, but you remember we had that really nice summer like 2 weeks ago, and then we moved back into autumn, which we seem to have hit now. We had this high pressure over the UK, over this sort of Northern Europe, and the jet stream was going past up over Norway and Iceland. And that's what you want to do. You want to have this nice sort of stable barbecue weather, what I call barbecue weather. So it's really nice to be outside, really nice and warm. Rubbish for deep sky observing because it gets very hazy, but for planetary observing, it's very good because you've got this nice stable air. And the other feature you need to remember as well is your local environment. So when we were on Tenerife looking out over the sea, of course, we have very stable air. Whereas, of course, if I'm observing in my garden, if I look out towards the south, luckily I'm looking out over farmland and trees and stuff. So there's not a lot of sort of poor seeing from my local environment. Whereas if I go to the front of the house and I have to look when the planets were lower and I couldn't see them through the trees, and I shot over the front of the house, over the rooftops, you could see the heat haze coming off the roofs. If the planets went past a chimney or someone's boiler vent from their central heating, you could just see the air go all turbulent. So your local environment can also have a real impact as well. And when I have that little gold telescope and I was working away, that's my travel telescope, I used to put the telescope in the car for an hour or two. So if I came home from work, it was a beautifully clear night, I put the telescope in the car because I was observing, just in the car park at the front. put the telescope in the car so that it was you could cool down to sort of the ambient cool conditions. If you've got a telescope and it's in your house, it's say, I don't know, 20 degrees or whatever, 20 degrees Celsius in your house, you put it outside, it's whatever, 0 degrees Celsius outside, you're going to get a heat haze coming off your own optics. So there's various things we can do to improve the chances of our seeing by catching the planets from the meridian, looking after our local environments, where you choose to observe from. And the best seeing is on those days, or those nights rather, of high pressure. So let's jump over then to the moon. Now, we mentioned earlier the moon isn't a planet because, of course, the moon orbits the Earth. But I've took this photograph a few months ago, and that is obviously the beautiful crescent moon. And when I was looking, I thought, oh, that's strange. There was this star next to it. And when I looked, I thought, oh, that's not a star. You can actually see there it's got the elongated rings, and that was actually Saturn. But what I want to show you in this picture is notice the angular size. So there's Saturn. Look how small it is compared to the craters. So Saturn, even with its ring system, is smaller in angular size than these sort of large craters on the moon. And of course, Saturn, obviously it's much bigger than the moon. It's just that much further away. And Saturn's one of the bigger planets as well. It's certainly bigger than Mars. It's oppositions. It's bigger than Mercury and Venus as well. So when we want to capture these features, that just shows you how small in angular size looking at the planets are. And certainly if you compare it to, say, deep sky objects, I know the Andromeda Galaxy is probably the biggest deep sky object sort of outside of the Milky Way itself. That's a picture of the same telescope with the same camera, the crescent moon, or sorry, half moon, and then the Andromeda Galaxy as well. So, you've got to remember that Saturn is really small in this sort of field of view. And that's why we've got this challenge of trying to find these small details. We need magnification to punch through this, but then we're a hit as we try and punch through the seeing. So looking at the moon then, there's a picture I took in 2020, and that is in the morning sky, and that is the crescent moon. You've got this little star alongside it, so a little disk, and that's actually Mars. And in the morning sky, as the moon slowly advanced over a period of about an hour, it looks like the star's actually getting closer to the moon, but it was actually the other way around. It was the moon got closer and closer and then covered Mars, and we have this occultation of Mars. But again, there you are. There's Mars in the morning sky, and again, tiny little disk in comparison to the planet itself. But I took that photograph, took that picture, using nothing more than the phone, the smartphone I had in my pocket, and I had one of these little camera mounts. Looked it through the eyepiece, and there you are. You can see the moon up there. And there's the picture on the screen. So you don't need, and the point of this is you don't need to sort of have high-tech gear and high-resolution cameras and big telescopes in garden observatories. You can get away with, a pair of binoculars and just literally a smartphone. And so at night time, I was using that same setup and actually photographing the moons of Jupiter as they went round, from night to night. They changed position, Io whizzes round, and you've got the planets the moons all changing position. That's great fun, just trying to track that. And you don't need to have a big telescope to do this. You can just use it with a pair of binoculars. And I did this project in the summer of 2006. I had my pair of binoculars. My daughter was actually born in May 2006, so you can imagine the state of my mind in June 2006. But Jupiter was really low from when we lived in our old house, and between us and our neighbours we had a 6-foot high fence. And so when I used to get sent down at whatever that is, 10-11 o'clock at night, to go and get stuff for the baby, for mum and baby, I used to think, oh, if it was clear, Jupiter would be visible over the top of our neighbour's fence, our 6-foot tall fence. So I used to grab the stuff, quickly grab my binoculars, and I used to plonk the binoculars on top of the fence. And then I would estimate the number of sort of Jupiter diameters between the sort of moons and Jupiter, the disk of Jupiter as well. So that's just pen and pencil, or pencil and paper sketches. But it's quite cool actually. So you can see, for example, Callisto, the outermost moon of Jupiter, on its orbit as it went round. What I should do is sort of properly space them out in terms of time, because of course sometimes I wasn't physically capable of observing, or we didn't have clear skies. So it's not every single night I was observing, but you can actually track the orbit of Jupiter's moons. And so that's just with a pair of handheld binoculars, notebook and pencil in the summer sky. I don't know what my neighbours thought of the pair of binoculars suddenly appearing on top of their fence at about 10 or 11 o'clock at night. And there's loads more you can see in the solar system, you know, with just a pair of binoculars. You can track asteroids. We've seen some of the comet sketches as well, follow the outer planets as well. But I soon realized that I needed to get a telescope, and I upgraded to a little 5-inch refractor, a Skywatcher refractor. And that's one of my pencil sketches. You can see I'm not a very good sketcher, particularly of planetary objects of that thing, but that's Mars in, was that 2003? And you've got there, say, Syrtis Major, this sort of large feature on Mars, this sort of wedge-shaped feature. And that's been sketched and observed for centuries now. And interestingly, up here, you get this white area called Hellas. That's a huge impact basin. That's one of the massive impact basins on Mars. You've got the sort of polar cap as well. And so even though I've photographed this scene, I can actually say, well, I've actually seen it as well. I've seen it in real time through a telescope, you know, or real time as a telescope allows to get that, to show that. But as you can see there, I'm not a sort of great sketcher, although I really enjoy sketching, particularly of those planetary features. So being able to see that was wonderful. I was going to take a sip of water and then we'll go on to the next section. Right. So that was my pencil sketching of Mars. And what I want to do now is show you what I actually use now. And this is the same techniques, even though it's a very different telescope now, to image the planets. That little telescope on Tenerife and what I'm using now in the garden, in my garden observatory. And it's absolutely, I still can't believe it now. You know, that's my pencil sketch. Was that 20 years ago now? And that's the image as well. I've matched the two together, so you got the left to right, but being able to see these features, being able to photograph these features, I find absolutely wonderful. For example, down there is the Huygens crater, a few hundred kilometers in diameter, you know, photographed a crater on Mars, you know, from this sort of garden shed. You've got the morning cloud as well. If I get back up one, you got morning cloud as well there forming on the limb of Mars. So you get to see these real features, you know, through the power of the image processing. So this is what we're going to do then. So that's Jupiter in the evening sky. It's me going into the observatory. We're just doing a quick go to Jupiter. And there it is above the telescope. And on the camera, on the laptop screen. So that's the raw feed. That's what we're going to do. And that's what we're going to process tonight. So we're going to turn that raw, grainy camera feed into that image. As we were saying earlier, that's the real thing. That's what we're battling. We've got to punch through that seeing. So how we're going to do that then is we're going to set up what you've just seen in that video clip. And we're going to capture a 2-minute video file using a high-speed camera. So we're shooting at about 100 frames a second. So over that 2-minute video file, we've got about 12,000 frames. So we're going to have all those frames, and what we're going to do is we're going to pass it through freeware, pass it through software, and it's going to sort out those 12,000 frames. We're going to reject all the blurry ones, you know, all the ones that have been distorted by the atmosphere. We'll just keep the sharp ones, and we're going to stack them one on top of the other, and that boosts that signal to noise ratio. That means we can then process it and bring out all these hidden details. They're all there in the data. It's just being able to process them and bring them all out. Someone in our club called it automagically the other day because it's all there in the data, and it's just using the software to bring it all out. So that's the first video frame. So we've got 12,000 video frames to sort through. That's the first. That's literally just when I press record on the laptop. The software is going to find the sharpest frame. But as you can see there, it's very grainy, very peppery, and that's because we're shooting at 100 frames a second. So it's only about 10 milliseconds long. So although we've got lots of nice sharp details, of course, has a very poor sort of signal to noise ratio. So it's a very peppery, grainy sort of texture. And that's why we need to stack them together. So we've actually got 1,000 hundredths of a second pictures on top of all there. So we've actually got a long duration picture that makes it nice and smooth, brings out all that detail. And that's why we can then sharpen it and do things like resolve a disk of the moons as well. So that's the process we're going to follow through. And this really is quite amazing because it's all free software. So our friends who do the deep sky imaging, they have to pay for their software. They have to pay for PixInsight and all that sort of thing. For planetary imaging, it's all freeware. It's a bit annoying that they're all different freewares. I wish someone one day would come up with a one package that makes us, be able to do it all, from the capture, the stacking, and the sorting, and the sharpening. So we're going to use FireCapture to capture the video imagery. We're going to use auto stack it to sort and stack it, and then we're going to use Registax to sharpen it. And then, of course, if you've got Photoshop or an equivalent, if you've got GIMP, then you can add the labels and all the details as well. So let's go through the process then, and that's all on this telescope here on the C11. This time we're looking at Jupiter. We're not going to be looking at Venus. And this is FireCapture as it stood in the day. So we're using our camera. We've got the pictures there. We've got all the controls here to record the video imagery. I'm going to reduce the frame size down so we're not recording all this empty black space. I'm using what's called a region of interest. I'm going to reduce that down and just capture Jupiter and the little moon as well, so we're not using up loads of file space. So I've got my 12,000 video frames, my 2-minute video file. Any more than 2 minutes, of course, Jupiter's own rotation will start to blur the image. You've got to be careful of that. So 2 minutes is the maximum you can use for Jupiter. So we're going to have loads of these video files. I'll leave it just recording, capture video file after video file for about an hour, or as long as I can stand. And then, yes, go and sort them out afterwards. So we're then going to pass that video file into AutoStack-It. And AutoStack-It was made by a chap called Emil, I'm not going to pronounce that, Krykamp. Completely butchering that name, so my apologies. But Emil has made this software and he made it free, and that's why it's got the Dutch name, AutoStack-It. And it's doing some quite clever maths. What it's doing, it's breaking down the image into all these different squares. And it's actually sorting through 12,000 or 11,249 video frames, finding the sharpest squares in each one and then recombining them back together. So it's doing some pretty hardcore maths. That's why, obviously you couldn't do this by hand. That's why we do use the software to do it. So I've told AutoStack-It to break it into little squares, and we're going to stack 1,000 and 2,000 frames. So off it goes. You're going to make a cup of tea when this happens because it takes a while. And it's gone through the 11,249 video frames, and it said number 3,166. That was your sharpest, and that's what we can see there. But as I was explaining earlier, you can process that. There's not enough detail in that. The exposure is too short. So we're going to tell it to go and stack the video frames, and then we're going to pass it into Registax. And Registax is this sort of software sharpening tool. What it does, you've got all these sliders and you move it across here. And I never knew how to do all this sort of stuff. And I started to, sort of make it up as I went along. And someone showed me all you need to do, and this is very useful if any of you use Registax, is click the use linked wavelets, and you slide this one all the way across, and you add your sharpen and add a bit of denoise to taste. So if I go on to the next picture, that's what I've done. I've added my sharpen, added my denoise. And in that process, you can resolve features inside the storm belts on Jupiter. You can see the moon's a little disk. You've got all this wonderful detail that's, frankly, beyond the image, the capabilities I have to observe. So that's how we do our lucky imaging. So just to recap then, 2-minute video file, any more than that, and Jupiter's own rotation will distort the image. Nearly 12,000 frames, 94 frames per second. That was the first. That's literally when I pressed record on the laptop. Sorted it all out. That's the sharpest, but again, we couldn't process that. So we stack 1,000 in this case into that nice, smooth, but not very detailed image, and then sharpen it. And lo and behold, all the data's there, all the details are in the data. And just by following through that, and that's all on freeware. And one of the things I forgot to mention, so I'm going to mention it now. When I go to the bookshops and when we go into town and my wife's busy buying whatever, handbags and all that sort of stuff. I like to browse the second-hand bookshops, and I bought this book the other day, and it's written by Dobbins, Parker, and Capin, and back in the sort of 70s, 80s, hopefully you can see that's better. Back in the 70s and 80s, these were the sort of Damien Peaches of the day, and they were doing this sort of high-resolution photography. There's a picture of Saturn, for example, high-resolution observing of the planets. But of course, they were using film cameras. So when you took your exposure, because you had to take, say, a half a second exposure with a film camera, no matter how good your telescope was, no matter how good your observing location was, of course, you lost out for the atmospheric seeing. So the old film photography, which is, in this book, was nowhere near as good as the old visual observers, because the visual observers with their notebooks and pencils could spot in those brief moments of clarity, oh, there's details there, and they'd add that to the sketch, and there's details here and add it to the sketch. So over a few minutes, you could pick out all these processes, and that's exactly what we're doing here, but just using the software rather than relying on the artistic skills here. So it is amazing, and it's only because, of course, webcams, digital cameras, digital processing, that we amateurs can piggyback on the back of it. So that's the lucky imaging, and I love the fact it's called lucky imaging, because you are just relying on brief moments of clarity rather than being like a professional astronomer where you put your observatory on top of a mountain, you choose where you were observing. Of course, we have to observe from our houses or our gardens or a local site to make the most of that sky. So that's why it's called lucky imaging. So one of the other features I found as well, particularly when the planets were much lower from the UK a few years ago, was that if you looked at the planets, you have this blue and red fringing, and it's the same effect as when you look at, say, for example, a sunset or a sunrise in the morning sky. You've got the red down low and you've got the blue up high. That's what we're seeing, the same effect through the Earth's atmosphere. It's acting a bit like a prism and splitting it into blue and red. And of course, the lower the planet or the lower the star gets, the worse that effect goes. There you are, there's the video of it. And again, you can see the seeing there. And that red tinge just down there, and that blue tinge there. And if I color enhance it, you can see it some more. So that's what we've got to, as another feature as well for planetary observing. And I tried to photograph Mercury, that's in 2020. So it was only a few degrees above the, in the evening sky. About this time of year as well, looking at that. And literally, it was just a spectrum. There was no visible disk at all. So I was talking to one of the other guys in the club, and he said, what you need is an atmospheric dispersion corrector. And what this is, it has two lenses inside it. And you wiggle these little handles here, these little metal handles, and they counteract the prisms rotate and counteract the prismatic effect of the Earth's atmosphere. So with that device, you can then actually resolve, get rid of that prismatic dispersion, that color distortion, and actually, in this case, resolve the disk of Mercury rather than having it appear as a spectrum. So I think, yes, looking at my notes here, Mercury was 13 degrees above the horizon when I did those two different images. And by putting the atmospheric dispersion corrector in, now you can actually see some of the, see it's a little disk. So I thought I'd just include this one again, because this is sort of how I got into sort of planetary imaging. So when I was, say, talking to a friend of mine, that's the camera I've got, the planetary imaging camera, an ASI 224, which I've had for years now and still really enjoy using. Quite an affordable camera. It's not a big full frame camera. It hasn't got any cooling on it as well. So it's a very affordable setup. And I was talking to someone in the club, and so I bought that camera and as I got into planetary imaging. And I then realized that I needed, the planets are small. We were talking about the molar, they've got that small angular size. So I actually bought a 2-inch filter, sorry, a 2-inch Barlow, because of course you need to amplify that those small discs and bring that up. So I went and bought the Barlow, and the problem was it then became very hard to focus because I was now at high magnification using that Barlow. Every time I touched the focuser to get it to focus, the image would shake all over the place. So I then sought financial permission to then buy one of these Crayford focusers that go on the back of the telescope. And I fitted a sort of simple auto Skywatcher autofocuser onto it. So I've now got motorized, hands-free, vibration-free focusing. So I don't have to touch the telescope now to focus. And then, of course, the planets were still quite low in the evening sky a few years ago. So then I had to go and buy the atmospheric dispersion corrector as well. And my wife said to me, she said, hold on. She said, you wanted to get into observing the planets. She said, you bought your camera. And then it's just been one more thing. Oh, now I need the Barlow. Now, because of the Barlow, I now need the motorized focuser. Now I need the atmospheric dispersion corrector. So do be careful. It is a slippery slope, obviously. And this is all about just making it better. You don't need to have, well, obviously, other than the camera, I don't need to have any of this, although it is very useful and nice to have. But my wife calls this just one more accessory thing. You only go out to buy a camera, and 6 months later, I've actually bought 3 or 4 more accessories to go with it as well. So that's how I go about capturing my planetary imaging. What I'm going to do now is do a quick summary. We'll go from planet to planet, and I'll just describe my favourite planetary images I've caught over the years. So we'll start off at little tiny Mercury. That's what I caught out in Tenerife in 2018. And Mercury's really hard to photograph. I've only seen it, I don't know, 5, 10 times in whatever that is, nearly 30 years of observing. And it's, very low, it's very small, it's very close to the sun. Particularly for us, up in the UK, it's only visible a few times of the year. So I've really struggled with this one because it's a bit bigger than the moon, but smaller than the Earth and a lot further away. But in 2016, Mercury actually passed over the surface of the sun. And we had this tiny little black drop effect. And I set up too late. By the time I was working at the time, so I sneaked off for a few hours. And I wish I'd caught Mercury that was going over that prominence. That would have been quite a good sight to catch. But it makes you realise how small Mercury is when it's in front of the sun, because, of course, that's its closest approach to the Earth. That's its closest point when it's between us and the sun. And you can see there, the curve of the solar disk, how small Mercury is, even at when it's at its largest size. That was the picture, I showed you that earlier, of me capturing Venus. But this was brilliant because we had such good weather in 2020. I actually managed to put this little montage together from sort of October all the way through to sort of April time, as Venus started on the far side of the sun, came round and undertook the Earth on the inside. And as it gets closer and closer to the Earth and undertakes us, we get to see more and more of the nighttime side, less of the daytime side, more of the nighttime. But of course, it's closer to the Earth, so it gets quite big as well. So I really quite enjoyed following the phase of Venus as it went through as it undertook us on the underside. This is one of my favourite pictures, actually. I think one of my favourite ever observations. This obviously is Mars, that same opposition in 2020. And this is, if you look here, that is Olympus Mons. So that's the highest mountain in the solar system. That's a volcano on Mars, an extinct volcano, and again, captured with a relatively small garden telescope, in southern England. But if you look down here, this region here is called Tharsis because it's all the volcanoes on Mars are in this region here. And you can see them there as Mars sort of rotates from image to image. Oh, that's the Mariner Valley as well. So that's that sort of Grand Canyon on Mars as well. But if you look here, we've got these other volcanoes as well, the Tharsis volcanoes. And you can see here, we get a little cloud start to appear. There's a little white cloud, and it becomes an elongated object there. And I didn't know what this was, so I sent this to the BAA, to Richard McKim, and said, what have I captured here? And he said, what that is, he said, that's the winds on Mars going up the volcano. They're traveling up the volcano, and they're condensing into a cloud on the summit of Mars. So I've actually photographed a cloud forming on a volcano on Mars, which I thought was quite cool. I went back to work, when we were allowed back into work occasionally, and the next day I was in the office, and I said to people, I said, how are you this morning, Mark? I said, really good. I said, last night, I was photographing these volcanoes in my garden. And they said, what do you mean photographing volcanoes in your garden? I said, sorry. I said, they were on another planet. So yeah, photographing volcanoes on Mars from a garden. And of course, was it December last year, 2022, we had the opposition of Mars, and at the same time, the moon passed over the surface of over Mars, and that's an absolutely wonderful sight, having the lunar surface and then looking across at Mars as the moon slowly passed over. I should put the video in of this as well, but maybe I'll find that after the talk if you want to see it. And that was absolutely wonderful. It was -8 degrees C. when that happened. I had my mug of tea as I was setting up. It was about 4 in the morning, so I set an early alarm. Absolutely spellbound watching this. I was so spellbound I forgot to drink my tea, and it sort of froze solid at the bottom of the mug. And I was telling this to my friends. We've got some friends who live out in Saskatchewan, right out in the middle of Canada. And they said -8 degrees C. We'd have been in t-shirt and shorts at that temperature. They were at -40 that day. So they laughed when I said -8 degrees Celsius was cold. Right, let's jump to Jupiter. So this is some time-lapse photography I've done. So this is what I quite like about, say, observing the planets. They're real things. They happen. They change. So what we've got here is Jupiter with my borrowed camera. We put the infrared filter on, and we've got 2 moons down here. And when was that? 2015. At 2015, the Earth and the plane of Jupiter's moons, we were all in the same plane. So Jupiter's moons, instead of passing one above each other, actually crossed each other, and they actually have an eclipse. So what we did, I'm going to start off with a wide field view, and then I'm going to put the Barlow in. So let me press play if I can find it. Turn my laser pointer off. Play. So that's the wide field of view. So you can just see the great red spot as well. And we've got Io and Ganymede. I'm going to put the Barlow in. And they actually passed over the top of each other. And you can see there as well. Oops, pause it. There we go. I pause it there. You can see the angular size as well. You can see how one moon is bigger than the other. But I think this video footage, this was the best night I've had of Jupiter. I think this is not last summer, but the summer before. And this was absolutely amazing because I recorded those video files, but for about 2 hours. You've got a moon coming in here. There's Ganymede, casting its shadow on there. There's the great red spot. Another moon reappears from the back. And I stacked the best frames of that picture and turned it into that. So I've got features inside the great red spot. I've got Ganymede, surface markings on Ganymede. There's another, I think that's it there. There's a moon there as well. That's its shadow being cast on the surface. And then the third moon reappeared from behind. And I was just absolutely spellbound. It was one of those nights where there was just no seeing. You know, this atmosphere was just clear. You know, there was no turbulence. It was just still, and you could see it. And I just thought, this is going to be really good. And it was absolutely wonderful. Being able to watch this as well, you know, going back to looking at galaxies or Andromeda Galaxy, yeah, you're never going to see something like this if you're looking at the deep sky. Yet, by watching this over about 2 hours, you know, being able to see the moons sort of dance in front of Jupiter was really quite cool. And to have the great red spot as well. So there's Saturn. That's the picture I took in 2018 on that trip to Tenerife. And you can see there, that was when the rings were wide open. So we got the really good view looking down at Saturn. This is the best picture I took the last year in 2023. But you can see how much narrower the rings are now with the rings are starting to close up. And some of the reports on cloudy nights, Saturn's rings, of course, are even narrower again, because in 2025, we're actually going to go through a ring plane crossing. So Saturn's rings will sort of disappear from view as we cross, as they become edge on. So it's something to watch out for. And it'll take a few years again for them to widen up again and we'll be able to see them like we did a few years ago. So let's jump out. We'll leave the gas planets behind. We're going to jump out to the ice planets. And we were very lucky. It's quite hard doing sort of time lapses of the planets of the outer planets because you need a number of consecutive clear nights. But we did have a run of good weather. Was that 2020? And that's the C11. So I've got the moons of Uranus as well. So photograph the moons of Uranus. They're all named after Shakespearean characters. What I'm going to do, if I press play, I went out every night at roughly the same time and actually caught them as they went round Uranus. Obviously skipped over one night as well. That's why it sort of jumps around a bit. But it was quite cool being able to see those moons going round and round from night after night. And I did the same thing looking at Neptune. And what I didn't realise until afterwards, Neptune's moon will actually go the other way. And it's not a natural moon like we see it on Jupiter, you know, where they were going from left to right. Triton, Neptune's moon, is actually a captured Kuiper belt object. So it actually orbits the other way round And I hadn't realised that until I actually saw it firsthand. So if you watch this then, nearly a 6-day orbital period. So there's the moon going past in its orbit. And luckily that star was in the way, so I could use him as a reference point to line each picture up each time. But I thought that was quite cool, being able to see the the moons of the outer ice giants. The light time or something from Neptune is like 4 hours. We're right at the edge of the solar system, and yet being able to see its moons as they orbit the planet was quite wonderful. So I've used binoculars and small telescopes. We've looked at Jupiter. We've looked at sketching on Mars. We've gone through the equipments for planetary observing. We've talked about the seeing and the atmospheric dispersion. And we've also then just gone through the high resolution imaging. I say, if you want to see more of that, let's say the videos are all on Refreshing Views, so have a look at that. And those are my contact details. If you want to reach out, feel free as well. And I'm more than happy to take any questions.
Thank you very much, Mark. Well, just quickly unmute our club room. If you could just share your presentation for the moment, so we can have the gallery view back. Again, as normal, hands up in the club room, digital hands online, as Paul would say. Leads me to say thank you very much for the talk. I enjoyed every moment of it. I don't know about everyone else. However, I can say that I just caught a little bit of very, very high praise from the room from our chairman, and I quote, "He's not a bad lad, is he?" And that was during your Jupiter images. So I think he was impressed with that.
Oh, thank you. That's very kind of you.
So if we have questions and answers, just hands up in the room and digital hands online, please. Is someone going to kick us off? Mr. Peter Lloyd, please, if you can unmute yourself and ask your question.
Yes, thank you very much, Mark. I also think of myself as a planetary observer, but my pictures don't hold up anything to yours, which are absolutely marvellous. I had 2 questions, and one of them slipped my mind. You mentioned the advantages of the atmospheric dispersion corrector. I too have one of those, but frankly, I tend to find it more trouble than it's worth. I find setting it terribly fiddly, and so I now do it in Registax, which has a similar feature built in at the end. I wonder whether you tried that and how you compare it.
Oh, right. So I've always used the tool in Fire Capture, so I presume it's the same sort of technique in that you use the software and color enhance it. So that's where I use mine. I can actually see it, but not to the same. So if you put an eyepiece in, you can see the benefits as well. But I do find it makes a subtle difference, because we're so much further north. I'm sure, if we lived in the Caribbean, like Damien Peach goes out to Barbados, or, people who live down in Florida, where the planets are overhead. So you don't get that atmospheric dispersion and they're nice and high. But it's almost essential, I think, from the UK, being particularly when they're low. But yeah, I use the software tool in Fire Capture to do mine.
It does the same thing, does it?
Yeah. You get the 2 little red. I had it on the picture earlier, the sort of red-blue circle, and you've got to get the 2 to line up perfectly.
Oh, that's in Fire. I don't use Fire Capture, so I'm not familiar with that. But yeah.
Yeah, no, I find it works really well. You never get it precisely right because the seeing is always jumping around anyway.
Well, exactly. Yes.
Yeah. When I was at the Winter Star Party, they had a telescope set up one night looking at Jupiter. And that's where I thought, oh, this is what good seeing is, when it's just still. And you can see, the disks, the moon, you could work out which moon of Jupiter was which moon by their colour and their size.
Oh, goodness me.
And I thought, well, I could never see that from the UK. They're all dancing in the turbulence. And you said a kind comment, sorry, Peter, you said a kind comment about the pictures. That's because I haven't shown you the rubbish ones. There's plenty of rubbish ones I could show you. Well, that's just it's like watching the highlights on the football. Everyone looks good in the highlights.
I'll tell you what, I wish I could produce anything approaching what you've shown us. Yes.
Okay, thank you very much, Peter. So we have a Mr. John Lynch, if you'd like to unmute yourself and ask your question, please.
Hi, Mark. That was an excellent talk. I really enjoyed it.
Oh, thank you, John.
I noticed when you were doing your processing using AutoStacker, you didn't use drizzle. I'd have thought you might have used it at least 1.5 for planetary. Is there any reason why you don't? Or?
So I do if planets are small. This is really diving into the weeds now. So so because I've got a f10 telescope and I put the ×2 bar, I'm shooting at f20, and then you look at your pixel size of your cameras, and basically drizzle's a way of the software can interpolate between the pixels, and so therefore you can pick out sort of finer details. So it's a bit of a, it's the same technique that Hubble uses for high resolution images.
Yeah.
So if I'm shooting Jupiter, which of course is a nice big disk, or Mars when it's at opposition, I don't use drizzle, but I do if we're looking at, say, a small planet. Yes, if I'm looking at Mars well before opposition, then I will use drizzle. So I do use that. Do that 50% boost to the size. But the problem is if you've got Jupiter, is already a pretty big disk on the screen, just because it is a big angular size for a planet. If you use that drizzle again, you do get much more detail. So it's kind of, with the shooting at f20, it's kind of empty magnification, if that makes sense.
Yeah. That's it. Yeah. Okay. Thanks very much indeed, Mark.
Cheers.
So, anything from in the room? We have a Roy online. Roy, please.
Hi, Mark. Thanks for the talk. Very interesting. I was interested that you photographed Uranus in particular and got the moons. I mean, presumably it's two shots of the planet and the moon separately. When I've done it, I must admit, even the long exposure to get the moons, sort of the brightness of Uranus sort of intervenes. So trying to edit out Uranus when I'm doing the moons is very difficult. I just wondered how you managed to get such sharpness of the moons.
Yeah, so you're absolutely right. So if I use the telescope, so when if you've got a big telescope, you can actually see the moons if you really crank the power up. But the human eye can tolerate the bright disk and the faint moons, whereas you're quite right, the camera can't. It's too much of a brightness difference. So you're right, it's the same exposure, because the moons are still in the data. I just have to stretch it more. So I'd take a nice picture of the planet. So I've got my nice blue disk, or greeny blue disk, or whatever color Uranus is supposed to be. And then I would then stretch it, bring out the moons, and then superimpose my picture of the planet on the top, if that makes sense. So yeah, you're right. It's a composite.
Similar to what I do, I must
say. Composite. What I interestingly found was that Neptune, it was easier to get Triton, Neptune's moon, than it was to get Uranus's moon, because it's several magnitudes fainter. So you haven't got that big brightness difference. Yeah. Plus, of course, it's further away. So Triton in sort of angular size was further away from Neptune than Uranus's moons are from the planet. So I found Triton actually easier to photograph than Uranus's moons.
Yeah, I always find, I mean, Miranda is very close, and I always get really excited when I get Miranda.
Have you got? I've never got Miranda. I got the 4. I got the 4, but not the 5th. So, you got it. Did you get it, Roy? Did you get Miranda as well?
Yeah, I've had it a couple of times, and I'm quite. Well, as I say, it's very close, and Uranus it's always in the way. It's you're spotting it in the force of Uranus, to be honest.
Yeah, it's so close in, isn't it? Have you done Mars's moons?
I haven't. No, I mean that's the next stage. But I mean, Mars's opposition this coming winter, it's one of the distant oppositions. So, and I failed last time round, which was the August opposition 2 years ago. But hey ho, I did like you. I got the volcano. I got Mount Olympus, which
Fantastic.
I was quite pleased with.
Yeah. Oh, fantastic. Yeah, so I got it in the 2020, got Phobos and Deimos, but they're just little specks, so I've never really bothered to go back and capture them again.
Thank you.
Cheers.
Thank you, Roy. So I will quickly jump in with a couple of comments here. Apart from whilst listening to Mark, I've started suffering a little bit with aperture envy now. So I think I'm going to go rush out and go get the biggest aperture telescope I can and try put it on the pier in the garden and then shoot absolutely nothing with it for the next sort of 3 or 4 years, I'm sure, with the weather. But I'm wondering, you've used SharpCap there, which is a wonderful tool, but you know, sorry, FireCap. I'm wondering whether you've ever got down SharpCap or anything like that. If you know if there's any difference in maybe some tips if you've been down that route on how to record, or whether it doesn't actually make a difference.
So I personally don't think there's a difference between fire capture and SharpCap. It's a bit, I don't know, Canon or Nikon, whichever you're used to, because you're controlling the camera. You're not doing the processing. You know, the camera's doing the work. You're just controlling the camera. So I don't think it makes a difference in capture. Now, what I do like, so I showed you the pictures earlier of SharpCap looking at the galaxies and doing that stacking on the screen, you know, using it as, I call it the best eyepiece I've ever bought. Being able to see all those features inside the galaxies. SharpCap's got a process now that we can do that live in real time for the planets. So I want to explore that this autumn. So I used it last year. So you're capturing your video of Jupiter, and the computer's then stacking the best frames in real time as well. So you then get the joy of observing, you know, you see that image build up, the sharpness, you can apply your sharpening in real time and get to see, and then record your data to then process it afterwards. So yeah, there's a SharpCap sort of live view of the planets, live stacking of the planets as well. So I'm really looking forward to using that this season, you know, when the days start getting a bit shorter, the nights start getting a bit longer. So I do recommend, yeah, it's 6 of one, half a dozen of another. I didn't realize when I started how important that fine focus is. That was the one thing that really surprised me. When you're observing, you know, with your eyes fairly tolerant, and your eye, of course, can focus as well. So your eye can tolerate a little bit of in focus, you know, a little bit of out of focus as well. And of course, the camera can't, it's got no autofocus. So being able to do that, particularly the planets dancing and the seeing, it's very hard to judge when it's precisely in focus. So that's why I really recommend having the motorized focuser. I found that really useful, being able to have that vibration-free focusing. If I'm looking at, say, Jupiter, I'll try and focus on, I'm just using the screen, I'm not using a mask or anything like that. You know, focus on the moon and try and bring out all those, you know, when it's at the best tiny little disc, best little dots you can get it, then you know you're in focus.
So are you using any software systems for your focusing now, or you
just done by, do it by eye.
Okay, fair enough.
I mean, you can do, and there's no, I just don't. I mean, some people do, you know, go and find a star. Make sure your star's at the same altitude, because of course you're going to get different atmospheric effects depending on how high it is or lower it is as well. So go and find a star that's at the same altitude. You could then use a focusing mask or software focus on that. And then, of course, check as well, because, of course, as the planets rise and set, your telescope's going to cool down as well at night, so it will contract slightly as well. So do keep on checking your focus as well. The Celestron C11, that's one of the things that really annoys me about it, actually. And I keep on thinking one day I must upgrade it. But you focus by moving the primary mirror. The primary mirror moves up and down the telescope. So you get it really nicely focused. It's all looking really good. And I've just suddenly realized that I've disappeared because the sun's going down, it's got dark, and I haven't turned the light on. So what happens is the primary mirror then settles as the evening goes on, and so you've got to keep on refocusing because it sort of settles down. So that is one of the annoying things about the Celestron C11. And so yeah, so focusing is really important. Recommend SharpCap for the live view and the live stacking as well, but both will control your camera. I'm just going to go and turn the light on, and I'll listen for your next question.
Not a problem. Just before we pop on to Mr. Peter Lloyd, I just want to put it on recording and on the record, especially for John Lynch. So you're saying the live stacking is basically like a sea star, but with a grown-up telescope?
Yes, if you bear with me.
Excellent.
So 1 second. If I go to, I'm just looking up where I recorded it. So I think I did it last autumn. Just trying to find it. Jupiter Live, there it is. So if I can just quickly nick your screen back, if I share screen 2, share. So this is it. So that's my. So there's going to be an advert, isn't there? Just get the advert. So that's me in the shed, and there it is. Mute that. But yeah, so that's me. You see, you got all the slots, so you can put the denoise, you can do the fine focus sharpening, you got all that, and it's stacking live. I told it to stack 2,000 frames, and you can see there the image is building up. And it's doing it live. So there's a shadow of a moon, but you can see as time goes on, all the fine details start to appear. I'll skip forward a little bit. Yeah, there you are. It's sharper again. So that's a live stacking of Jupiter, live at the telescope. And there's all the data coming down the USB cable. So you don't have to go and post-process it to go and see it. So yeah, it's in SharpCap, the live planetary stacking enhancement tool.
Pretty sure that some of our members are going to use that. I certainly am, because I have a grown-up telescope. Right, so Mr. Peter Lloyd again, please.
Yeah. Can I chip in again then?
Absolutely.
Just a few comments on some of the things you've been saying, Mark. I've also had a go at the satellites of Mars and failed miserably. I think the thing which I did manage, which amazed me most, there was an occultation of, I think it was a 6 magnitude star by Triton.
Oh, wow.
I forget when it happened, and I managed to observe it. The video was actually on my website. I couldn't resolve Triton and the star, but what I did see was a drop of the light intensity as Triton went in front of the star. And I think the thing that amazed me most about it, not just that I, a mere amateur in a fairly light polluted environment, could actually observe it, but that it actually happened when they predicted it would happen. And if you think of the accuracy with which you must know the position of that miserable little 6 magnitude star, you must know the position of Neptune, the position of Triton as it goes round Neptune, the position of the Earth. They knew exactly where the track of that shadow, which is smaller than the Earth, because of course Triton is smaller than the Earth. I thought it was absolutely amazing, that precision.
That's fantastic, isn't it?
Yeah, the question I thought of, it came out of what Roy was asking you about getting the faint satellites alongside the bright planet. The one that really impressed me was your picture of the occultation of Mars by the moon. You've got this beautiful view of Mars, but it wasn't completely swamped by the bright moon. And that must have been a huge difference in light levels there. Yeah. I wonder how you managed that.
Right, I will have to nick the screen back 1 second, and let me just go and find it. I should have included this in the actual thing as well. Just trying to find it. Where is it? Oh, there it is. Take the screen share back. Share my screen. So you're absolutely right in that I did cheat. So that's me in the garden. I think I just paused it there. I think there's the moon and Mars. So you can see there, you got the disk, and that was the raw footage. Obviously sped up a little bit. But because Mars was at opposition, so it was at its brightest and the biggest. So it wasn't swamped. It wasn't like, you say, photographing the moons of, the outer planets.
Oh.
So that was the live. If I go, no, it doesn't let you scroll back on a short video. But yeah, that was like that, and I had a So I chose my best pictures of Mars, best pictures of the moon, did the same process again and just composited them together.
Ah, so it was
Wasn't
two quite different photographs.
no, there's roughly the same. So there were two photographs because it was moving. And then so I just lined them up perfectly. So I think I just said, right, there it is, there, and then took the two over the top. So I took a picture of Mars, took a picture of the moon, composited them together, but then watched it in real time, so I knew where to put my Mars.
Yeah, I understand. Basically, I did the same thing when I was trying to do. I had much poorer picture of Mars, and actually, it was an emergence that I was trying to do, and I missed it. But I caught enough of it to catch Mars and, as it were, move it back. Which was
I completely forgot about that. I was so stupid. I was so chuffed to catch it. I was like really buzzing. And I thought, oh my God, I've got a full day at work now. I haven't been up since 4 a.m. And then people were saying, of course, by 10, 11 o'clock in the morning, it was reappearing. I thought, oh, I completely forgot that bit.
It's much harder because you don't know exactly where it's going to appear.
Oh, of course, yes. So no, it was pretty good. And being able to see it in real time, and I was amazed how quickly the moon moves. Of course, you look at the moon, you don't realise it's moving against the background stars. Obviously, it is because it has to go around the Earth. But when you got the Mars sitting still and the moon slowly marching across, it is going at a fair old rate when it went over.
It does. Yes, I've seen it. Yes, thank you.
Oh, fantastic. Now, yes, I'm pleased you got the reappearance. I completely missed that. I completely forgot about it. So you got it, it was probably warm by the time you saw it then, Peter. It must have warmed up from that very cold night.
Sorry, which one are you talking about?
The Mars reappearance.
Oh, yes, I can't remember now. I can't even remember when it was.
Okay, thank you. So I'm just going to ask for just a final scan online and in the room to make sure we haven't missed anyone with a burning desire to follow up with a question. So we're going once, twice, 3 times. Excellent. So that just leaves me to invite everyone to warmly thank Mark for what was, I firmly believe, an excellent talk and a brilliant introduction on photographing planets and what you've achieved in what is a short time, but, a long amateur career. So thank you very much.
Oh, cheers. Thank you for having me.